Hello, welcome to section 8.2, which deals with multiplying and dividing rational expressions. So in order to get into this, first let's recall multiplication. If you multiply, it's just like how you would multiply fractions, right? So let's say, for instance, you have 1/2 times 3/4. Well, you just multiply straight across. So that would be 3/8, right? So the same applies to expressions. You have two rational expressions, let's say some P over Q times R over S. Well, you just multiply straight across, right? So it would be the product in the numerator over the product of the denominators. Now, the nice thing is for rational expressions, factoring is pretty amazing. So basically, if we just factor every numerator and denominator and write them as all one product on the top and all one product on the bottom, you can cancel out any common factors, okay? So let's say here, if we were to do that kind of method, so if we factored everything, so let's say here, this would be 2 times 5 over, let's say 4 times 7, or 2 times 2 times 7 for 28. And then 8 would be 3 times, and then 15 is 3 times 5. So everything that is basically across from each other diagonally would cancel out. But let's say we write it as one whole fraction just because. So 1, 2, 3, 4 2's times 5 on the top. And on the bottom you have 2 times 2. And I'm rewriting them in just lowest to greatest, right? So that's the numerator and the denominator. So we basically just cancel what's in common. And then you can leave the rest here, like 4 over 21. Okay, so sometimes here people ask, well, can I, and just like I said, you can cancel diagonally. These 2 2's cancel, these 5's cancel, and then your product is still the same, what's left over, So you would still have 4 over 21, so just so you know. Now let's go ahead and do that, but with x's and y's. So here you have 2x times 6x times y cubed, and that's going to be all over 3, and then x squared times y squared times y, that's just y cubed, but let's just leave it like that. So notice these two x's will cancel out. That cancels out this x squared. This 6 is actually 2 times 3. So that's going to cancel out. And you're going to left with this here is y cubed, and then you have a y cubed here, so they cancel out. So then finally you're just left with 4 on the top, and that's it, 4. 1 on the denominator, which is just 4. Okay, so seen another way, if we had multiplied the constant part, so that would be 12, and then the x's, x squared, y cubed on the top, and on the bottom you would have 3x squared, and then the y cubes. You could see that those will also cancel. Sometimes it's easier. So 12 divided by 3 is just 4. Okay. So let's go ahead and do some more factoring. So this first one would be n times the quantity n minus 7. On the bottom is n plus 1 times n plus 1 times, and on the top is n plus 1 over 2n. So then you can see a pair of n's will cancel. This n plus 1 cancels one of the n plus 1's, and then what's left on the top is n minus 7, and the denominator is just 2 times n plus 1, and you can leave it that way. Okay? All right, let's do a couple more. So factoring each part individually. So here in the top left, you have x plus 5, x minus 5, then times x plus 2, right? Which is from the other one, all over. And then what does this factor out to? Negative 10. So that it equals to negative 3. So that's negative 5 and positive 2. So you have x minus 5, x plus 2. And then, of course, that's times x, right? So then the ones in common cancel. These x plus 2's cancel out. These x minus 5's cancel out. And you're left with x plus 5 over x. And that's it. All right, so then let's do a couple more. So then you have here 16 minus 4x, factor out of 4. You have 4 minus x over, and then 2. If I factor out of 2, I get x minus 6. And then times, and then here, 2 factors of negative 6 that when combined give you negative 5. So the factors of negative 6. So you can have a negative 6 and a positive 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Okay, so that's going to cancel. That's going to factor into x minus 6, x plus 1, all over difference of squares. So that's x minus 4, x plus 4. Okay, so so what cancels out? All right. Well, remember, look, these are the same but in different order. So I can cancel them out, but I'm left with a negative, right? So what else can cancel? These x minus 6's can cancel out, and that's it. So basically, you have 4 divided by 2, which is 2. This here, 4 over x, so this is just a thought bubble. You don't have to write this out. But 4 minus x over x minus 4, remember that's equal to negative 1. So then you have times negative 1, so that's a negative 2. And then you have an x plus 1. So then x plus 1. And then denominator is just this canceled out, right? Became 2 on the numerator. So then all you have left is an x plus 4. And that's it. Okay. Let's do another one because we love examples. So here, GCF is a 2, x minus 3. And then over, then the bottom is x minus 3, x minus 5. You can check me if you want. Okay, times difference of squares, x plus 5, x minus 5, right? That's this part here. And then all over 2 times x plus 5, right? So these are being multiplied. It's the same thing because you're just multiplying straight across. Now I can start canceling. The 2's cancel out. The x plus 5's cancel out. These x minus 3's cancel out. These x minus 5's cancel out. Oh my goodness. It's equal to 1 because everything canceled out. Okay, so division of rational exponents. So dividing rational exponent expressions, is basically, remember, it's just like fractions. If you have 1/2 divided by 3/4, that's the same as you keep the first one, you change it to a multiplication problem, and you flip the second fraction. Okay, so that's going to be 2/3. Okay, so you multiply the first fraction by the reciprocal of the second. Okay, so let's say here, and of course we're factoring along the way. So we have x plus 9 over 6 minus x here. This is going to change to a times. Then on the top, you have x minus 6. And on the bottom, you're going to have this factored x plus 9x minus 9. Now that it's a multiplication problem, we can go ahead and cancel out. These x plus 9's cancel out. These cancel out, except that they leave a negative, right, to become negative 1. And then denominator is just x minus 9, and that's it. Okay, let's do a couple more. So here, first fraction stays the same. 3n squared over, common GCF is n. I don't know, I wrote 4 because I just did. It would be n times n minus 4. This division symbol becomes a multiplication, and then denominator, then this goes up here and this goes down here. So what is the factors of 10 positive that add up to negative 7? So n minus 2, n minus 5, yeah? And then in the denominator is the old numerator, so I factor out a 9n, and I get n minus 5. So now I can go ahead. So again, I remember just to recap, we changed the division to a multiplication problem, and we switched the numerator with the denominator. So this denominator is now the numerator. This guy's now this guy, and then this one here is now in the bottom, okay? So now we can cancel. We can cancel out 3 goes into 9 3 times. These n minus 5's cancel. I have n times n, that's n squared. So these two n's cancel out with this n squared. So then finally, you're just left with n minus 2 on the top, and then 3 times n minus 4 in the denominator, and that's it. Okay. Let's see. Let's do one right here. Let's do kind of a little bit more complex. So this one here, all you have to do is write this over 1. And now, boom, it's a rational expression. Okay, so what does that mean? Now we can multiply. We can divide and multiply, right? Using the rules that we all know and love now but at this point. So difference of squares on the left-hand side, a plus b, a minus b, over 3ab times 1. This is a perfect square trinomial, people. So that's a plus b squared, or a plus b, a plus b. Okay, so let's cancel out. An a plus b cancels out. And that's about it. So then you just have a minus b, because a minus b times 1 is just itself, over 3ab a plus b. All right. So that's it for that one. What if you have something like this? Holy moly. Well, this here is another, it's AKA a division, right? So I can rewrite this problem as 6x squared minus 7x plus 2 over 4x minus 8. That's being divided by, and then you have 2x squared minus 7x plus 3 all over x squared minus 5x plus 6. So now it's looking like something we know to do. So let's go ahead and do that. We're going to factor each one. So what are the factors of 6x squared? Oh, so we need to do, you can do AC method, right? Or you can do, 12. And then what are the factors of 12 that add up to -7? That's -3 and -4. And then you can, rewrite 6x squared minus 7x plus 2. 6x squared minus 3x minus 4x plus 2, factor by grouping. 3x times x minus 2 minus 2 times, 2 times x minus 1. Let's see here, minus plus 2 x 4x plus 2. Did I factor something wrong? Oh, yes, I did. Sorry. I totally factored it wrong. Right here. I'm sorry. I'm like, why isn't this working? Okay, so here I took a GCF out of 3x. That left me with 2x minus 1. Here I take a GCF of -2 because there's a negative in there. And then that gives me 2x minus 1. And then now my factors are 2x minus 1, 3x minus 2. So all that work, right? So we have this here. So that becomes 2x minus 1, 3x minus 2. GCF in the bottom is 4x minus 2. Oh, that's nice. And then times, we flip this. This becomes our new numerator, right? X minus 2, x minus 3 all over. And then the denominator, we have 2x squared minus 7x plus 3. So that's going to end up being, what, 2x and then minus 1 minus 3. So that's going to give you what you want. So then you can check it using AC method, however you want. So now let's cancel out what's in common. These x minus 2's go away. These 2x minus 1's go away. These x minus 3's go away. And you're left with 3x minus 2 over 4. And that's it. Okay, this will be our last one. Last one, it looks kind of crazy, but it's not. Just factor, and then cancel out. So let's go through it. GCF, 3x minus 2. Denominator, 4x minus 1 times, this is here. What are the factors of -3 that become, positive 2? So that would be minus 1 plus 3. And then on the bottom, what are the factors of -10 that combine to become -3? So minus 5 plus 2. Okay. And then here times, and you flip. You flip the reciprocal, right? And you get the reciprocal. So factoring out an 8, you get x plus 2 on the top now. And then factoring out a 2, you get an x plus 6. Okay. Now let's look and see what we can cancel out. All right, these x plus 2's can go. These x minus 1's can go. What else? Let's see. 4 times 2 is 8. So these 3 can go. And I think that's it. So on the top, you have 3 x minus 2, x plus 3. And on the denominator, you have x minus 5, x plus 6. And that's it. Okay, that's it for 8.2. Good luck. Happy studying, and I will see you in the next video.